Good morning, students. Before going through the study, we should remember these points which keep us safe and healthy at the time of COVID 19. First, we should always practice to wash our hand with a good hand sanitizer, which can be alcohol based, or we can use a soap and we can wash our hand for about 20 seconds. We should, not we can. Okay, now the practice the social distancing. It means you should always keep distance from the other person, which should be about 6 feet. It is very important for your safety. And always wear a mask. It is safe for you and for the other person also. And consult your doctor before using any medication. If you are going to use a medicine, then before stopping the medicines, you should always consult your doctor. Even though if you are going to use any medicine, you should always consult your doctor. Okay, don't take any medicine without any consultation. And it is very necessary that if it can be possible, then you should work from your home. It means like studying, we are studying at home for her and for your safety. And do not ignore the symptoms. If you're having some symptoms about the cough and cold, then please consult your doctor. And after that, you should always keep physical and mental health. You should always maintain your physical and mental health. You should always do exercises which will keep you healthy and safety. Okay, now we will start the chapter. We know that we are doing the chapter work energy of physics, and for this chapter, for the numerical question of this chapter, we should always remember the formula of this chapter. So we are just going to revise the formula of this chapter. Work is equal to force multiplied with the displacement. And in case of if the force applied is zero, if force is applied on an object, so we can say the work done will be zero. Or in case if there is no displacement in an object, we can say the work done will be zero. So this is the one formula for the work, that is F into S, where F is the force applied and S is the displacement. Second one, from this formula we derive the another formula, that is W is equal to 1 upon 2 m V square minus U square. And if you want to know how we derive this formula, it is very easy, that we know that W is equal to F into S. And force is equal to how much? In second chapter we have learned that force is equal to m into a, mass multiplied with the acceleration. You should always remember the meaning of all the symbols which we are using in the formula. So F is equal to m into a, where m is the mass and a is the acceleration, multiplied with the displacement. Now, for this acceleration, we can use the equation of motion for finding this acceleration. Suppose we don't have the acceleration, we have the velocity of the object. Then what will we do? We will use the formula for the acceleration. From the second chapter force, we know that the third equation of motion, this was also in the first chapter, that is v square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a acceleration, s is the distance or displacement. So we can say v square minus u square is equal to 2as. Or for finding the value of a, we can write it like a is equal to v square minus u square upon 2s. Okay, this is the formula for acceleration. So in place of a, we can write it like v square minus u square from 2s. We get it from the third equation of motion into s. S will cancel out with s. So we will get 1 upon 2 into m v square minus u square. Okay, so this is another formula for the work done, and most probably we use this formula for most of the numericals. So these are the two formula for work. Third one, we have learned kinetic energy. And for kinetic energy, for finding the kinetic energy of a moving body, you know which object have the kinetic energy? The body which is moving has the energy in the form of kinetic energy. So, or we can say the energy possessed by a moving body is called the kinetic energy. So it means the kinetic energy depend on the velocity. So the formula for the kinetic energy is 1 upon 2 m v square. This is the formula for kinetic energy. And these are, since this is the energy and this is the work done, and work done is stored in the form of energy. So the SI unit of work done and the energy is joule. Okay, आपको हमेशा ये याद रहना चाहिए. So this is the formula for kinetic energy. And what is the formula for potential energy? Potential energy, the energy possessed by a body due to virtue of its position. आपने कोई ऑब्जेक्ट उठा के यहाँ से यहाँ रख दिया, so अब आपने इसकी पोजीशन चेंज कर दी. So the energy possessed by this object is the potential energy. And since this object is placed at certain height, so we can say the potential energy is depend on the height, that is m, g and h. What is m? M is the mass of the object, g is the acceleration due to gravity, and h is the height to which you place an object. So this is the formula for the potential energy. Now another formulas are power. Power is equal to work done upon time, W upon T. Power is equal to work done upon time. It means how much work you have done in unit time is called the power. And the SI unit of power is watt. Okay. So this is the formula for the power. And you can find the work done by using all these two formulas. Sixth one. So this is the formula for the power. Now the formula for the energy consumed. Energy consumed. Energy consumed is equal to power multiplied with the time. If you want to find the energy consumed with the unit, commercial unit, that is kilowatt hour, then first of all you should convert the power into kilowatt. If you are putting the value of power in kilowatt and time in hours, then the unit for the energy consumed will be kilowatt hour, and we can write it like unit. Okay, otherwise the energy, we know the SI unit for energy is joule. So for the commercial purpose, you need a large unit which is kilowatt hour, or we can say it unit. So these are some formula which we used in this chapter for numerical question. We are studying the chapter work energy. In this chapter now, today we will do NCERT exercise, some numerical questions of NCERT exercise. This is the question number 4th. Question number 4th is certain force acting on, you can take your book for seeing the question. Certain force acting on a 20 kg mass. Whenever I give you some questions or somebody give you some questions, first of all you should write the values which you get from the question. Like certain force acting on 20 kg mass. It means, what is this? This is the mass of the mass. We can represent it by using the symbol m. It is 20 kg. Okay, changes velocity from 5 meter per second to 2 meter per second. What is this? We know that initially the velocity of the body is 5 meter per second. So by which symbol we represent the initial velocity? First of all, we will write it like initial velocity. Initial velocity. And we represent it initial velocity by using the symbol u. It is 5 meter per second. So the velocity changes to 2 meter per second. It means it is the final velocity of the body. So the final velocity is equal to 2 meter per second. Okay. Calculate the work done by the force. So what you have to find? You have to find the work done. Work done. We represent the work done by using the symbol W, and while final velocity we represent it by using the symbol V. So you should remember all the formulas which you have learned in this chapter. Like for the work, we know that W is equal to work done is equal to force multiplied with the displacement. This is the first formula, and we derive the formula for the kinetic energy, and we find that W is equal to 1 upon 2 m v square minus u square. This is another formula for the work energy, 1 upon 2 m v square minus u square. So you can derive this formula, but for the particular question you don't have to derive this formula. You can use this one. Like W is equal to 1 upon 2 into what is the mass? Mass is the 20 kg and V square minus U square. V is 20 square minus 5 square. So, okay, one first formula is the F is equal to W is equal to F into S. Another formula for the work is equal to 1 upon 2 mv square minus U square. We have learned this formula in derivation of kinetic energy. So, we can find the W is equal to, here 10, 20 square is 400 minus 25. You can use the uh, formula for identity of maths like this: a square minus b square. So you can write it like a plus b into a minus b, or any method which is easy for you. So 10 into, it will be 375. So 3750 joule. We know that SI unit of work done is joule. So I'm doing some numerical questions only. If you have any problem in other questions, please ask me. Question number 5. This is another numerical question. A mass of 10 kg is at the place of A on the table. So first, what is given in the question? The mass of the object M is equal to 10 kg. Is placed is at the point of A on the table. Suppose this is the object and it is here at the point A on the table. It is moved to a point B. So we are moving this object to the point B. This is the point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? The gravitational force is always work in the downward direction. So this is the direction of displacement, like this, and this is the direction of force. I explained you, if the direction, if the angle between the displacement, we can say the angle between the force applied and the displacement is 90, in case the work done will be 0. By applying the formula W is equal to F into S into cos theta, and we know that the value of cos 90, this angle is of 90, so the value of cos 90 is 0. Since the value of cos 90 is 0, so we can say work done will be 0. So if we are moving an object horizontally, so the work done by the gravitational force will be 0, because the angle between the displacement and the force applied is 90. Or if this angle is of 90, so we can say the work done will be 0. So you can explain it like this: since we know that, since the angle between displacement and force, or we can write it gravitational force, is 90, so work done will be 0, is equal to 0. Okay, this was the question number 5. Now the question number 10. In between the question 5 to 10, like 6, 7, 8, 9, these are the theoretical question. If you have any problem in theoretical question, please ask me in your group, even though you can call me on my personal number. Okay, 10th question is, an object of mass 40 kg is raised to the height of 5 meter. So what is given the question? First of all, is given the mass of the object. Mass of the object, which we represented by using the symbol M, is 40 kg. So the mass of the object is 40 kg, is raised to the height of 5 meters. So what is this? This is the height, and we represent it by using the symbol H. It is 5 meter. This units are very important. Mass should always be in kg and the distance should always be in meter. So suppose this is the object and you are placing this object to the height of 5 meter. Okay, this is the object and we place it at the height of 5 meter. Okay, now above the ground, what is the potential energy? Okay, now we know the formula for the potential energy. Potential energy is equal to mgh. In last lectures I explained you why the potential energy is equal to mgh. So by applying this formula, we can easily find the value of potential energy. Mass is 40 kg, and what is the g? If it is not given in the question, the value of g is what? Then you should use the value 9.8 meter per second square. G is equal to 9.8 meter per second square. What is g? G is the acceleration due to gravity, into height is how much? It is 5. So 5 4 ja 20. 200 into 9.8. It will be 1960. Potential energy is the energy, so its SI unit should be joule. Okay, this was the question number 10. Now the question number 11th. Question 11th is, what is the work done by the force of gravity on the satellite moving around the earth? Okay, this is not a numerical question, but I'm going to explain you, because you should know why when a satellite is move around a planet or a earth, why the work done of this satellite is always zero. Suppose this is a satellite and it is moving around a earth. It is revolving around the earth. So the force of gravitation, why this is revolving around the earth, the centripetal force it will get from the gravitational force which is acting towards the earth. So means it is the direction of force. And the movement of this satellite is always like this. At this point, the direction of motion is like this. At this point, it will be like this. At this point, will be like this. So the angle between the displacement, direction of motion, and the force is always 90. So we can say when a satellite moving around the earth, the work done by the satellite is always zero, because the angle between the force and the displacement is of 90. So we can say the work done by the satellite will be zero. Now the next question number 14th. Question number 14th. In case of any problem, please ask me in your group, even though you can call me. An electric heater is rated 1500 watt. So what is this? We should know that the watt is the unit of power. So we can say the power of the appliance is equal to 500 watt. This is the 1500 watt. How much energy does it use in 10 hours? What is this? This is the time. And we represented time by using the symbol T and power by using the symbol P. So the time is 10 hours. Okay, you have to find the energy consumed. Okay, how much energy does it use? So in last lectures, we know that in last lecture we study that the power is equal to energy consumed multiplied with the time. Or divided by time. Power is equal to work done upon time. The another formula for the power is energy consumed divided by the sum. Sorry for this one. Energy consumed divided by the time. So for the formula for the energy consumed, we can use the formula energy consumed is equal to power multiplied with the time. So what is the power of the appliance? It is 1500 watt. Now one important thing is that if you want to use the commercial unit of energy consumed, you should always keep the power, it should always represent the power in kilowatt. So if you want to find the energy consumed in commercial unit, that is kilowatt hour, or we can say that unit, so you should always convert the power into kilowatt. And for converting this watt into kilowatt, we have to divide it by 1000. Okay, so power is equal to energy consumed is equal to power multiplied with the time. And for commercial unit, we will use the SI unit of power is kilowatt. So by dividing it by 1000, we can convert the power into kilowatt. And the time should be in hours, so time is 10. So by solving it, we will find it like 15 kilowatt hour, or we can write it like 15 unit. Okay, this is the energy consumed by the appliance. Now the question number 15th. Question number 15th is, illustrate the law of conservation by discussing the energy changes which occur when we draw the pendulum bob one side and allow it to oscillate. Okay, this is suppose an activity. This is a rigid wall, and we are hanging a bob here with the thread, or we can say it is a pendulum, and we place this pendulum to here. Suppose we keep what we are doing, we draw the pendulum to the one side and allow it to oscillate. What will happen if we place this pendulum here. It means we are drawing this pendulum to this point. This is the point A. Okay. And now, uh, and now leave it. What will happen? This pendulum will start to oscillate. First of all, it will go here to the point B, and again it will come to the point C here. This is the point C. This is the original position of the pendulum. And again it will go here to the point A and point B. Now the question is, why does the pendulum eventually come to the rest? What happens to its energy eventually? Is it a violation of the law of conservation of energy? Okay, no. This pendulum always follow the law of conservation of energy. According to the law of conservation of energy, we know that energy is always remain conserved. We can't destroy, or we can't generate the energy. So is this Bob follow the law of conservation of energy? Yes, because when we draw this pendulum to the point A, what will happen? We are going to change the position of this pendulum, so it will gain a potential energy. Okay, at this point A, what is the energy gained by this pendulum? It will be a potential energy. Now, before releasing this pendulum has only potential energy, and it don't have any kinetic energy, since the velocity at this point is always zero. So we can say at this point A, the potential energy is maximum and the kinetic energy is zero. So what will happen if we release this pendulum? If we release this pendulum, this potential energy is going to change into kinetic energy. At this point, when we release this pendulum, it will come from A to the point C, and when it is coming to the point C, its potential energy is changing to kinetic energy now. Okay, and at this point, at the point C, at this point which is the original position of the pendulum, at this point it has no potential energy. It will have the zero potential energy, and it has a maximum kinetic energy, because at this point the velocity is maximum. So we can say that at this point all the potential energy is changing into the kinetic energy. So the mechanical energy, it means the total sum of the energy, is remain constant. So potential energy change into the kinetic energy at this point. Now again, when this pendulum start moving at this point B, this kinetic energy is now going again changes to potential energy. And at this point, so now from the point C to B, the kinetic energy is changes to potential energy now. And at this highest point, since we know that at this point this pendulum rest for a moment, है ना, यहाँ पे आके रुकेगा फिर वापस चलता है. तो at this highest point, since the velocity is zero, so we can say it has no kinetic energy. It means its kinetic energy is zero now. So all the kinetic energy is changing to the potential energy. So it has only the potential energy at this point B, like this point A. So we can say in case of pendulum, the energy remain conserved, because at this highest point, it has only the potential energy, no the kinetic energy, and at this point PC, all its potential energy change into the kinetic energy. So at this point, it has only the kinetic energy, no potential energy. And again, when it moved to this point, its kinetic energy change into the potential energy, and it has only the potential energy at this point and don't have any kinetic energy. So the energy remain conserved. So why this pendulum is stopped after some time? Because of the resistance of the air. It has to do some work to resist the air. यहाँ पे हवा के मॉलिक्यूल्स हैं, ये मूव करेगा तो हवा के मॉलिक्यूल रेजिस्ट करेंगे इसको मूव करने के लिए. तो जो इसका वर्क था, वर्क डन कहाँ खर्च हो गया? उस रेजिस्टेंस को कवर अप करने के लिए. तो इसीलिए आप कह सकते हो कि एनर्जी कंजर्व रहती है पेंडुलम के अंदर. ये रुक क्यों जाता है? क्योंकि एयर का रेजिस्टेंस इसमें लगता है. So you can write the theory about it. Question number 15. Now the question number 16th. Question number 16th is, an object of mass m is moving with the constant velocity. So what is the mass of the object? It is given that the mass is m. moving with a constant velocity v. So the initial velocity, we can represent it by using the symbol u, and we can write it like initial velocity. It is v. How much work should be done on an object in order to bring the object to be rest? If you want to bring this object to be rest, it means its final velocity will be 0. Final velocity is equal to 0. So how much work you have to done? We know the formula of work is equal to 1 upon 2 m v square minus u square. This is another formula for the work done. So by using this formula, we can find the work done. 1 upon 2 into m is how much? M. And what is the value of final velocity? It is 0. Initial velocity is v square. So we can say the work done will be 1 upon 2 mv square. Okay. This is the work done by you if you want to stop the object. Now another question. This is the question number 17. Calculate the work done to be required to stop the car. So first we should write what is given in the question. That is, we want to stop the car. It means the final velocity of the car will be 0. Final velocity v is equal to 0. Stop the car of mass 1500 kg. This is the mass of the car. Mass we represent it by using symbol m is equal to 1500 kg. Moving at the velocity of, means it is the initial velocity. Initial velocity is how much it is? It is 60 km per hour. Okay, this is very important that you should always convert the velocity in meter per second. 60 multiplied with the 5.18. So by multiplying it by 5.18, we can convert the kilometer per hour into meter per second. 300 upon 18. Yes, we can cut it by using by 300 upon 6. Oh, again we can cut it by 2. 50 upon 3. Okay. 50 upon 3 meter per second. This is the initial velocity of the car. So you have to find the work done to stop this car. So work done is, we know the formula 1 upon 2 m v square minus u square. Now put the value 1 upon 2, mass is how much? 1500 into v square. V square is v0 minus u square. U square is how much? 50 upon 3 square. So it is 1 upon 2 into 1500 multiply with the minus 2500 upon 3 3s are 9. So we can solve it. 3 से cancel कर लेते हैं. 3 times 500. Okay, you can calculate it. 2 से 250, sorry. And okay, 25 into 25, it will be 625. 1 2 3 upon 3. So we can find it in points in decimal. Minus 3 to just 6 0. This, it will be like this, or we can write it also in fraction. So it will be itna joule. You know why the work done is negative? Because suppose the car is moving in this direction, so the work done to stop the car is in opposite direction. So we find the work done in negative. This is the question number 17. And now the question number 20. This is the numerical question. Question number 20. Find the energy in kilowatt hour consumed in 10 hours by the 4 devices of power. So in this question, what we have? We have the power. Power is how much? It is 1500 watt. How much devices we have? We have the 4 devices. Okay. And we are using this device for time, that is 10 hours. We have to find the energy consumed. We have just learned the formula. Energy consumed is equal to power multiplied with the time. So by using this formula, we know that power is 500 watt. Or for commercial unit, we should always convert it into kilowatt. So by dividing it by 1000, we can convert it into kilowatt. 500 upon 1000 kilowatt. Multiply with the time. So this is the energy consumed by the one appliances. If you want to find the energy consumed by 4 devices, it will be energy consumed by the one devices multiplied with the 4. 1, 2, 3, 1, 2, 3. It will be 20 kilowatt hour. Sorry, not per hour, kilowatt hour, or we can write it like unit, 20 unit. This is the energy consumed. Okay, these are the numerical questions of NCERT book. If you have any problem, please ask me. Okay, bye.